illustrates the design with specification. Aerospace leads the team in the launching of the device. Materials explains the properties of materials used in device or improvements made to attain the desired performance. Disaster risk responsible for waste management. Theoretical explains the science concept where the device is based upon. Construction leads the team to assembly of the device. Mechanical checks the structural integrity of the device planned. We designed this blueprint by making sure the weapon is secured inside. The parachute is made by manila paper connected by the use of strings or yarn. The biological weapon is inside the box covered by the paper to secure it. We designed this device to protect and avoid the spread of the biological weapon throughout the air when we drop it on the ground. We make sure to cover up tightly our weapon or box in order how high it falls, it will never be broken. It is built by the use of a hard box and covered up tightly side by side to avoid the leakage. To drop our protective weapon, we use a tight yarn or strings to connect the paper-made parachute and test it to make it success. The newspapers that's rolled up serve as the firm walls around the space where the egg will be placed. It becomes the foundation of the device and works as a shock absorber for the egg upon the impact. Its symmetry will create an increased surface area on the parachute, so it will cause the egg to hit the ground at a lower speed.
How does a parachute work? A parachute is a device used to slow down an object that is falling into the ground. There are two forces acting in a falling object. First is gravity, and second is air resistance. As the parachute opens, the air resistance increases. Now the air resistance is more than gravity, so this slows down the parachute and the person can land safely on the ground. A parachute have a more prominent place in human history than many would think. Long before we took the skies in man-made metal birds, men were contemplating ways to safely carry a body from sky to the ground. How parachute works today is based on a primary design change. Rather than a round or dome-shaped parachute, the first and foremost feature of a modern parachute design is a ram air structure. Today, parachutes have a series of tubular cells that inflate as air is forced into each chamber.
First of all, I build a rectangular box that serves as a protective device that can easily hold the egg inside, which the egg serves as a biological weapon. Then I wrap the egg with a newspaper and manila paper inside to lessen the impact when it falls, so that it will not break. Then I use the yarn to connect the canopy and the box on the rectangular box to create a parachute. So the lightness of the material that I've used is compatible as it can easily be acted upon by the air, which enable air resistance.
Newspapers and manila papers are light materials. We made it firm and strong by rolling them. It is the best if the parachute is shaped as a circle because its symmetrical shape creates greater air resistance. With the provided materials, we also maximize its size. The way the surface area is greater and the air resistance is also greater. So the parachute will fall slower when compared to making a smaller circle. The strings were also lengthened to the maximum so that the air can act upon the parachute.
Consequently, it will do the least amount of impact of the enemy.
We launch our protective weapon to test if it is safe for air traffic. We plan to make 3 trials or height measurements when we drop the weapon. We make sure that the biological weapon cannot be broken. First, we drop the weapon 1 meter high, then 2nd meter high, and lastly 2nd floor house. If the weapon does not break, it is a success.
Transportation of the biological weapon include carton boxes, yarn or string, masking tape, and manila paper. We also included ruler since we used it for cutting up the string or yarn that we use for the device. For disaster risk, meaning who is or who are responsible for the waste management after doing the performance task, is also us as people. We were also the ones who are responsible for cleaning up everything, especially our surroundings where we did our performance task, and made sure that we didn't leave a mess. Lastly, while conducting the performance task or doing the performance task, we made sure that there are no possible risks that could affect or disturb our performance, and also the device